Now I know much more about overfitting.
Do you actually?
Yeah,
Okay,
absolutely.
That's great.
Yeah.
Are you afraid of it? Yeah.
I'm still more scared of zombies.
Oh, that's fair.
Fitting
That's fair.
is up there.
They're kind of similar, actually.
What way?
Hey, welcome back to Approximately Correct. I'm Alana Fish.
And I'm Scott Lowell.
This episode, we have Michael Littman,
Yes.
which is an amazing gift to the Approximately Correct listeners. He happens to be in town this week. He's here for the Reinforcement Learning Conference, which is in Edmonton this year, 2025.
Yeah, happening at the U of A.
Mm-hmm. It's been a really cool conference. Today actually is the last day of the conference. So Michael stepped away just to talk to us a little bit about some of the things he's done in his career, why he ended up in reinforcement learning, but then also his passion for communication about AI.
Yeah, and this is one of those conversations that it's always like, oh, I've got so much we want to talk about.
I know, we could have kept going for sure.
I mean, he's had a great career in reinforcement learning,
Mm-hmm.
but he's also held a lot of roles in the terms of like AI policy. So like he was the heading AI policy for the National Science Foundation in the United States.
Right, the director of AI.
Director of AI, yeah. And his most recent role right now is he started as the Associate Provost of Artificial Intelligence at Brown University.
Mm-hmm.
So he's working to kind of help them deal with this massive shift that we've seen in the last couple of years.
And across the whole university, which I thought was really interesting. So not just the people working on AI, but everybody impacted by AI, which is everybody. So.
Yeah. And he's also just a really funny guy.
Yeah, this was a joy to record.
Yeah, one thing I actually learned about him that we didn't talk about, but he's also was the star of the first ever email attachment. It was a photo of him and an audio of him singing with some of his coworkers.
Oh, to have been coming up at the same time as the internet.
Yeah.
I mean, I missed that.
92, I think it was. So. But I mean, it was a great conversation.
Yeah.
Really loved having Michael on, and now we'd love to share it with you.
So here's Michael.
All right, we're here with Michael Littman. Thank you very much for joining us today, Michael.
Yeah, thanks for coming, Michael.
Yeah, thanks so much for coming, Michael. No, wait, I'm Michael. No, I'm so glad to be here. Thank you so much for inviting me.
Yes, excellent. That's the appropriate answer. Nicely done. One for one.
Shoo.
There's a lot that we want to talk to you about today. But actually, just as we're recording this, you have finished, yesterday you did a keynote speech at the RLC conference.
I did. That wasn't stressful at all.
Oh, yeah. How was it? And like,
it was stressful at all.
yeah.
Yeah. No, it was great. It was very well received. It's a wonderful conference with, and the people are just engaged and interested, and they've got follow-up connections to make. And so after my talk, I was there for another 45 minutes of just like conversations with people about things. It was lovely.
Well, I can see why people wanted to grab you to talk after the keynote. You've had a pretty impressive and interesting career in RL. So we want to kind of go back, like, what was it about reinforcement learning that first interested you?
I was an undergrad student in the late 80s, studied computer science or computing science, we call it here.
Yes.
And that was my major. And I was sort of a cognitive science groupie. So the second most popular kinds of classes that I took were all in psychology and cognitive science in particular. And I took a cognitive science seminar, and then we were talking about machine learning, actually, about neural networks, which were kind of like really cute, fun thing at that time. And the psychologists were latched onto them too. Mm-hmm. This is like just after the backprop paper got published and so forth. So it was a heady time. And I was reading these papers about both supervised learning. I was like, but this isn't really the interesting problem. Like, how would I make a learning program that would say play tic-tac-toe? Mm-hmm. And so over the break from school, I just went home and I was supposed to be spending time with my family, but instead I was at my computer writing a tic-tac-toe learning program, and I basically invented like Q learning, right? Because it just seemed like the thing that was needed to be able to do the decision making. And so like that was a thing that I thought was the right problem to work on. Then when I got out of school and I joined a research lab, I said to my supervisor, David Ackley, here's the thing that I'm really interested in. What is that? Well, I didn't even say what is that. I was like, how would I study that? He's like, oh, the thing you're talking about is called reinforcement learning here. And he gave me Rich Sutton's paper on TD learning. Mm-hmm. And I read that. I'm like, this seems like it's very interesting, but I don't understand a word of it. And he's like, okay, well, we'll just bring Rich in to talk to you about it. I was like, wait, what? You can do that? These are real humans? They're not just like words on a page? And so we invited Rich to come give a talk. He talked about Q learning. He talked about work he was doing with Chris Watkins. And I was like, oh, this is fantastic. I definitely want to do this.
Oh, good. Oh, I love those moments. Those like serendipitous sort of, yeah.
Sounds like a really interesting path together. And I guess I know you've worked with Rich on, subsequent
I
projects
later,
and
yeah, I
things.
later got to be a colleague of his. So that was an exciting moment.
Mm-hmm. And so what kind of RL problems were you most interested in?
I wasn't motivated by the problems per se, but it was definitely the case that when I was like in high school and I was writing programs, I was very interested in sort of video games and programs that could actually like do the sort of things you do in a video game. So I'd make my own games because there was no way to download anything. There was no network. And so there's like I had a lot of games that were based on high jump because I just was fascinated by the high jump.
Like
And
the
jumping
sport?
over a bar. Yeah, just
Oh, okay.
jumping over. I just loved to jump over things. That was like weirdly satisfying for me as a teenager. So I had made a lot of games based on that. And I was like, oh, well, could I write a program to decide when to do the jump? So like, the character's like running up to the thing. If you jump too late, you run into it. If you jump too early, you crash down on it. Like you have to time it just so. Like what would that look like? And so I think I was very motivated by the kinds of tasks that were like the things that I liked to do, like getting around in the world.
And so supervised learning is not something you like to do.
In regular life?
In regular
Does
life,
anybody
yeah.
like that?
No,
Like
of course.
isn't there? It's funny, right? It's like supervised learning gets all the oxygen in the room.
Right.
But the fact of the matter is, what a boring thing.
Right.
It's like, here, just stay put. I'm going to give you lots of examples, and then I'm going to later ask you to produce other examples like that.
I'm going to tell you when you're wrong, but not why.
Well, I mean,
Well, that's more reinforcement learning. I will tell you when you're wrong, but not why. Supervised learning, I will tell you what you should have done.
Yeah.
And that feels so freedom removing.
Yeah.
maybe that's why there's so much attention, because people are like, I don't want to do this. Can we make a machine?
That's
do
right.
this?
We should outsource this to the machine.
this is
This is what
horrible.
machines are good at.
Yeah, I mean, it's an interesting question. Why? I've asked Rich this. Like, why did people start with supervised learning?
So Andy Bartow, who was Rich's supervisor, apparently gave a talk at the previous RLC conference, which I didn't get to go to because of weather delays. But apparently in his talk, he framed it as, no. In the beginning, there wasn't a distinction. There wasn't supervised learning and reinforcement learning. There was just like adaptive neurons, and you could make them do lots of different kinds of things. And so it really bifurcated downstream from there, maybe with the invention of backprop. But it's definitely the case that the very earliest work in machine learning was in both camps, right? There was work on checkers that was making decisions. It was very reinforcement learning like, but there was also work on recognizing things visually that was absolutely in the supervised learning camp.
Right before we started recording, I mean, you had mentioned that you kind of feel you are robotics adjacent, cognitive adjacent. So is there a certain thing that kind of connects them for when you see a problem or an area, you're like, oh yeah, that's what really appeals to me?
I did have this really interesting experience. I was the department chair of computer science at Rutgers. And it was an interesting moment because instead of hanging around with other computer scientists, I was suddenly hanging around with the other department chairs in the physical sciences. So there was a statistician and a mathematician, a geologist, a chemist, and a physicist, and me. That was the 6 departments that were part of this cluster. And one of the things that I discovered was I didn't feel like I had a lot in common with scientists, but then I met a sculptor, and I was like, oh yeah, he sees the world the way that I see the world. So for me, a lot of it is I like learning about things and then figuring out how to incorporate them into making something, right? So in computer science, for me, it's like, oh, here's a new algorithm. What can I do with that? Right? What does that enable me to do that I haven't been able to do in the past? And if it's a thing that like doesn't really enable me to do anything that I'd already been able to do or hadn't been able to do, that's not interesting. But if it's like, oh, this opens a door. This is now a new set of capabilities. And this is what I was hearing from the sculptor is that he would look at new materials and he would say, oh, how can I work with that? Does light pass through that? If light passes through that, does it change the light in an interesting way that I haven't been able to experience before? And to hear him describe it, that was particularly the sculptor who created the World Trade Center memorial that happens every year on September 11th, where there's just light beams shining up in the sky.
Okay.
He loves to play with light in his sculptures, and just hearing the way that he sees new things in the world, I'm like, that's me. That's how I see things too. Though of course it's not making art; it's like making algorithms. But like at some deep level, obviously that's an art.
Yeah. It's a
think
creative process for
It's
sure.
very creative.
It does. Yeah, that's right. That's right.
Yeah. And making. It is also making. I think there's sort of like a spirit of
And that was the thing that I just didn't get from my colleagues in the physical sciences. It's like they were learning and they were studying and they were designing these amazing experiments and they were having all kinds of conceptual breakthroughs. But then like, what do they do with those breakthroughs? They like write down the equation. Like, no, I want to make something with that.
What's the making of cognitive science?
Oh, why am I interested in cognitive science? Because that's what you're making with, is your brain, right? Like the brain is just the coolest thing in the whole darn universe.
Yeah, true. That's why we wear helmets.
And that's why we wear helmets, to protect our brains. And we wear them now when we commute and when we podcast.
Yes. We are all, if you're not watching on YouTube right now, we are all wearing helmets. I swear.
And if you are watching on YouTube, please ignore what Erlana just said.
We'll see you in the comments.
A lot of the work that you've done has involved kind of including human feedback into training RL agents. So I would love to know what kind of have you learned, or what surprised you about the way that machines can learn from people, or I mean, vice versa, really?
Yeah. So I think first and foremost, I'm really interested in how people can tell machines what we want the machines to do for us, right? The remarkable thing about computers that was not true of, I don't know, shovels or boxes, is that you can delegate tasks to them. And we have various mechanisms for actually conveying, we have a sense, I know what I wanted to do. How do I tell it what I wanted to do? And so programming languages are a phenomenal way of doing it. It's really the humanity's best construct at the moment for conveying things to machines, but machine learning is another channel to that, another mechanism that they can use to get that, and feedback, right? So in a sense, it's the thing is in the person's head, and the person's trying to get it out. So you asked about specifically the question of if we're trying to get a machine to do something through like positive and negative feedback. We're watching it perform, and then we're like, no, computer, bad computer, don't do that, or like, yes, thank you so much. And there's analogies to how we train animals and, I don't know, toddlers. Like there's a lot of times that we use that we don't have a very thick communication channel. We've really just got valence, right? Positiveness and negativeness. Yeah. And so that's the setup. And now I think the question was, well, what's something interesting that we've learned? So as a reinforcement learning person, I was always taught to think of the world as, well, there's rewards and there's punishments. And that's like positive and negative valence. So how do reinforcement learners work? Well, they try to act in a way that maximizes the positives that come in and minimizes the negatives that come in. And so I just assumed that when we're giving feedback to machines just directly, that's what we're trying to do. We're trying to give the positives that it's going to maximize, and we're trying to present negatives that it should try to avoid in the past. But it turns out, first of all, that's really hard to train algorithms to do that. And it's not naturally what people do. So we've run a bunch of experiments where we've actually had people watch a little animated video game character behaving and then giving positive and negative feedback. You're trying to train this character to get to this goal position, but not without stepping in the flower bed. All right. And so then the agent starts to move, and the person's pressing plus or minus to say whether or not they're happy with that behavior. Okay. What they don't do is create rewards and punishments to be maximized. It just doesn't work. If you actually take the feedback that they give and try to maximize it, you get these terrible behaviors where the agent will, like, for example, purposely step in the flower bed and then exit and then go back in and exit and get, where it's taking the rewards very, very literally.
Okay, because it's getting rewarded every time it steps.
That's right. So what it saw is that the person was like, the getting out of the flower bed made the person really, really happy. So it's like, great, I can set that up and I can reap the rewards. But that's not what they meant, right? That's not what people were trying to do. And so what we started to realize is that, in fact, people are providing something much more like a gradient signal, much more like a TD error that says the thing that you did compared to what we all thought you were going to do is better or worse. And that's like a second order thing, but it turns out to be, first of all, much easier for the learner to optimize. And second of all, just more natural for people to deliver feedback in that way, like their watch. And as long as everything is going according to plan, there's no feedback at all. It's just when the agent does something surprisingly bad or surprisingly good that they're like, yes, no.
Right.
And you need algorithms that actually expect that kind of feedback, because if they expect this other kind of feedback, they're going to do bad things.
And I mean, like that, I know a lot of your other work, I mean, you talked about a little bit, but the importance of not everybody who's going to be using models, especially as they come more of our daily lives, are going to be technical or going to be able to program. So could you talk a little work you've done on making things a little bit easier for the end user to program?
Yeah, I'm very interested in that question. Like, what does it mean for an end user program? I think partly it's because I'm fascinated by computer science and think that everybody should be interested in it. Yeah. When I started to learn and I had 2 younger siblings, I was like, oh my gosh, you guys, check this out. And they were not interested. I'm like, oh, I probably got to them too late. Someday I'll have kids. So then I had kids. And I was like,
have to listen
you guys
to me.
Come over. This is so cool. You're going to love this. And like, So now I'm like, okay, well, maybe the students who come to class are going to... But I've taught some classes at the university where it's an introduction to computer science for people who don't intend to be computer scientists. Like they're just interested in what is this about. And I've asked them after the class, like, okay, well, I taught you a little bit about programming. Are you using that in your daily life? And they're like, no, I'm not taking any more computer science classes. I'm like, no, that's not what programming is for. We didn't invent programming so that people could take computer science classes. It's this really powerful tool that you can use to delegate tasks to computers. Yeah. And the fact that they didn't feel like that was part of their daily life made me really wonder, like, what could we be doing to make this more part of everybody's lives? And so that got me interested in the question of how can we empower end users to tell machines what to do? And that's sort of how I got to that.
And that just so smacks of vibe coding. Like this stuff we can do now.
So So now if the goal was everyone should be able to program, and now suddenly, well, you could just talk to the machine and it's going to do stuff. People are telling me that this is a solved problem, and I'm not convinced that this is a solved problem in any way, shape, or form. Part of it is because the way that some people vibe code is it really is vibing. It's like, I'm going to put out some stuff. We'll see what I get back. Like, they don't really have a goal in mind necessarily. They're just like seeing what comes out of the interaction between us and the model. That's fine. That's super fun. But if you actually want to get something done, that's not the model that you want. You want to be able to say, this is what I want to have happen. Mm-hmm. And first of all, that's hard for programmers to do, to get these language models to actually deliver. Yeah. And then it's really, really hard for people who don't even know how to program. Like, I find the most success that I've had in telling language models the code that I want them to write is I ask myself, well, how would I break this down into subroutines if I were going to write the code? Yes. And then I say, here, this is the first subroutine I want, and it nails it. Yeah. And it's like, okay, here's the second subroutine I want, and it nails it. Like, I need them you put together in this way, and then it nails it. But if I weren't a programmer, I think that would be hopeless. Yeah. I would not break it down in that way, and I don't think it would work.
That's part of the skill of programming, is learning how to take a very big problem and making it small. And so maybe that's part of what we should be teaching. I think that skill is useful in more than just programming, like understanding problems.
I agree. So my daughter, when she was in college, she thinks like a computer scientist, but she has no interest in computer science. And that was very challenging for me. But what she did do is she did theater, and she directed a show with like 60 kids in it, where she's got the tech staff, and she's got the instrumentalists, and she's got the performers and the dancers. And watching her just get that complex organism to do what it was supposed to do at the right time in the right way looked to me a lot like programming. I'm like, I can't believe that I've never learned this skill. She somehow knows it as a college student, so like kudos to her. But I don't know why we're not teaching people how to. Maybe this is why I want to say how to use people better. But using people has a very negative connotation to it. But like, lead people to a mutually beneficial outcome, right? It's a thing that is actually really complicated, and it does have things in common with programming, because you have to think about what all the components are, the people, and what they're good at, and how they're going to interpret what you have to say. And just being able to hold that in your head and think it through is so hard and so important that I don't understand why that's not like the first thing you learn is how to work in a team.
I feel like some of that might be in business school, but I didn't do business as well. So.
But yeah, I mean, it does sound like, vibe coding is a place that can help with the technical aspect and the actually writing. But when you're talking about the way that you have to think about a problem, the fact that you just said, like, you have to set a goal to actually achieve something, that's something that it's not going to be able to do, at least right now.
That's right. I was also thinking about the flip side of this. And so we've run some experiments where we've asked people to tell other people to do a task. Because there's this wonderful literature that dates back to the 1980s of people, like beginning programmers, being given a task, like average this list of numbers. And weirdly, people who were like acing an Ivy League level computer science class, like half of them got that wrong. Like a really simple question, like average this set of numbers together. And I think the lesson that people took from that is, well, syntax is hard, right? It was the early days. It was in Pascal. Pascal was just a bear. You had to you have to remember the right word to end a block, and there's big begins and ends, but you didn't always have to use them, but sometimes you did. And it was a lot to expect people to really have mastered this vernacular. But what we did is the opposite. We said, okay, you're telling another person what to do. We're not going to teach you any programming language at all. There's no syntax. There's just language, and that should be really easy for people. Well, half the people couldn't tell another person to average a list of numbers or the equivalent. And I just thought that was super interesting, right? Because it was never about programming. It's about breaking a task down into pieces that you can actually communicate. Writing is hard. People, it's a struggle to write really clearly and precisely and not boringly and not ambiguously. And it's like, it's the same as that. Like writing a program is like writing, but for a machine.
Right. Writing is also the process of trying to get somebody to do something, but like in their mind.
In their mind, right? It's super hard. I mean, when you program, like there's some of that going on too. You have this very rich mental model of what's happening inside the computer. Where's the data now? What's the status of that data? Is it possible that it's gotten corrupted? And if so, how? Like so and you're right. When you're writing, you're doing that in a person's head.
Theoretical, hypothetical.
Similar to me. You could say vibe coding is as easy as writing. But guess what? Writing's hard. So we still need to help people get to that point where they can express themselves clearly.
Yeah. And I mean, I'd maybe able to also bring people to programming, though, because I feel like some people are just turned off by the nitty gritty of programming.
Parentheses.
Yeah. And syntax, as you said,
Yeah.
and blocks or whatever. And it does sort of seem ridiculous and arbitrary. And it is one of the frustrating things about learning how to program. I remember repeatedly going to the teacher and being like, it won't compile, but I've done everything correct. And it's like, you absolutely haven't if it doesn't compile.
Right. Your statement is provably false.
But, I mean, if you could kind of get past all that and work on what might be the more interesting thing to some people, which is the higher level problem solving, maybe some people will learn to love programming.
Yeah. I mean, I'm a fan of anything that lowers the barrier to entry without actually destroying the ability to get things done. I'm on board.
Yeah. And so do you think vibe coding is going to destroy the ability? Like, what do you think? Where are we going?
Well, I think the more that people work with it, the more that we're going to see where the rough edges are. And it's definitely the case. You can't just walk up to these. Like I heard, I'm not going to say his name right, but Ilya Sutskever, who coined the term. I watched one of his talks on this, and he's like, very comfortable vibe coding. And I was like, well, yeah, you'd also be very comfortable coding. And it's probably super fun for you because you're getting to skate at that middle level where you're deciding what the pieces are, but you don't have to get into the nitty gritty of balancing parentheses or whatever.
Yes, exactly.
And so, but he's already there. And so I don't think this gets us an easy path for everybody else to get on board. I think there's more work that we have to do.
Yeah. When it comes to programming, but I think we've all run into situations where, things are going smoothly, but then when a problem happens, like you need to rely on the expertise for troubleshooting. And if you don't have that background or that foundation already,
right. Everything grinds to a halt.
Yeah, you're not going to find where the problem is. So I know a lot of your work recently has also been in what we would term, I guess, AI literacy or helping people understand artificial intelligence. So I'd just love to know, like, how did that start to come to be?
Yeah, I think it's all part and parcel of the same thing, which is that I really want to spread the good word. Like, I think this is really interesting stuff. I think it's become more and more consequential in people's lives, and I want to make sure that they have the tools that they need. For a long time, it was me, like, not literally, but like knocking on people's doors, like, hey, you want to talk about AI? It's not like that anymore. Now, like, I think I had like 6 Uber rides in a row where an AI discussion started because the driver said, hey, you want to talk about AI? I'm like, funny you should ask. I would, in fact. What do you want to talk about AI?
Yeah. And I mean, you just started a role as the Associate Provost of Artificial Intelligence at Brown. That's the title, I think.
It's, I think it's the Associate Provost for Artificial Intelligence. Okay. I had gotten it wrong a bunch of times, so you probably, if you heard it from me, you made a mistake.
I might have taken it from a bio.
Don't take my word for it. Yeah. So it's one of these things where now I think lots of organizations are realizing, hey, AI has impact across everything that we do. How can we think about this? How can we coordinate this? How do we navigate this moment in history? And I was first getting exposed to that because I spent the last 3 years in the U.S. federal government. I was the division director for the AI division at the National Science Foundation. And so mainly what we did was evaluate people's grant proposals, and then some people got money. Like, that was the job. And that was already a big and complicated job because my division included human-computer interaction, AI, machine learning, computational neuroscience, biomedical engineering on the computational side. Like, so it was a somewhat diverse portfolio. Yeah. And we had all these wonderful people, and we were doing great stuff. But then 6 months into the job, ChatGPT came out. And so that was a mass freakout event at the level of the agency and the federal government as a whole. And so suddenly my role became to not just do my job, but also to help coordinate efforts across all of the National Science Foundation. So the geologists had questions about AI. The physicists had questions about AI. Well, the physicists thought they knew everything about AI. But needed to be talked to. Other agencies, the State Department had AI issues that they were grappling with. One of my favorites was the patent and trademark office. They were dealing with AI from like 5 different angles all at once because they could use AI as a tool in the work that they were doing, evaluating patent proposals. They were also getting patent proposals written by AI, and they didn't know what to do with those. And they were also getting people writing patent proposals about AI inventions. And so all these different dimensions all were coming together. And so across the whole federal government, there was just this need for some frank conversations about what do we mean when we talk about this? How should we set up policy with respect to this? But the U.S. federal government was not the only organization in the world that was impacted by this big shift. And so a lot of universities started to say, hey, we need to coordinate our efforts around AI. And my home institution happened to do that. And they put out a job ad internally. And I was like, I think I should do that. And so my job is to coordinate AI research, teaching, AI in university operations, AI policy, and communication around AI. And so there's just like so many things going on to try to weave all these pieces together. I don't know that universities will need a role like this in 30 years, but like right now, it makes an awful lot of sense to help just get everybody onto a similar page.
You seem like you have a very broad view of what's happening across institutions. So do you see any themes? Like no matter what the field, they're all thinking about.
I mean, the theme is there's AI everywhere, and generative AI is having a big impact. But no, that's the thing that's interesting about it is that it is pretty diverse.
Okay.
That the folks who are on the research side, they're wondering, okay, well, what does this mean? I'm a physicist. I'd like to use machine learning to help identify the results of some of the experiments and super fast, because these experiments are taking a fraction of a second to complete, and it would be great to not have a person have to do that or just store all the data. Just let some machine learning system deal with it. So they've got a set of issues that they're focused on. What's happening in terms of generative AI in the classroom is a whole really very different issue than that. I mean, part of it is the actual technology is kind of similar. And so there are not themes, but there's threads, I think, that go between them. But the real issue is, how do we apply this to this particular sphere, right? And as much as I would like it all to be about, well, AI, as I study it, it's really not. It's really about the things that people are already doing. How is AI integrating with that? And so it's going to be very diverse because people do very complicated and different things.
And does that tell you anything about how the world is going to be impacted by AI?
I mean, my view is definitely that it's a pocket sort of thing. So when I got into the federal government, there was a lot of discussion at the time about, well, we need to regulate AI. And I'm thinking, the analogy that was in my head was like metal. Like metal is like AI in the sense that it's useful for lots of different things. Right. It can hurt people. It can help people. And really what matters is not that it's metal, but like, are you using it in a car? Are you using it in a building? Are you using it in a weapon? Like those are very different use cases. And I think the AI use cases, it's similar, that we need to be, there's metallurgists who study the fundamental properties of the metal, and that's fantastic, and that's really useful across all these. But really, the discussions are about how am I using it in my particular sphere.
That's such an interesting metaphor I had never heard before. Yeah, we are also surrounded by metal. Metal is everywhere.
Yeah, right. And it really comes up in a very similar way. Like, I'm afraid of metal. Like, well,
not all metal.
Right. That's right. Yeah. No, it's interesting.
Yeah, but like everybody's concerns about metal are also different. You know, if you're building a skyscraper, you want to know how much it can hold.
That's
if you're
right.
Buying a car, you want to see what it looks like.
And that's focusing in on the use case. And I think that's appropriate in the AI space as well.
That's interesting. And it also sort of tells you the same, like, how does one regulate metal?
Yeah.
Right. Yes. Like, it's this very silly thing.
Right.
Yeah. And that's part of it.
So I guess it sounds like you got your work cut out for you in this new position.
It's going to be super interesting. I mean, I'm loving meeting the new people and on campus, like a different cohort of people than this, the computer scientists who I'd been hanging around with the last decade.
Yeah. So just a bit on that, you talked about the importance of that communication. I want to talk about your personal style, because I think AI can sometimes be a bit of a dry topic to talk about, but you, and I mean, just talking to you now, put a lot of humor. I know you've done like some work with like songs and parodies. Alana talked about the YouTube clip that I think it was overfitting. I think you were talking about.
Yes.
And you tuned to Thriller.
You overfit it, spit it out. You try to prune the tree, but find your set of points is shattered.
Now I know much more about overfitting.
Do you actually?
Yeah,
okay,
absolutely.
That's great.
Yeah.
That's fantastic. Are you afraid of it? It was supposed to sound a little scary.
It did seem a little scary.
That was the goal. That was the mood that I was going for. Yeah.
I'm still more scared of zombies, but like
Oh, that's fair.
Fitting
That's fair.
is up there. Yeah.
They're kind of similar, actually.
What way?
The issue with overfitting is that you train an algorithm and you maybe don't give enough data or for whatever reason, it ends up actually doing really, really well on the training data that you give it, but doesn't generalize to new situations. So it's like it looks normal, but it's kind of dead inside, like a zombie.
There you go.
Wow. Is that really what the inspiration was?
A little bit. Like the way that I do a lot of my parody songs is I think about the topic and I think about the sort of the emotional valence of it. Maybe that sounds weird. Like I'm going to do a thing on like graph theory. Like, how does graph theory make me feel? It's like, well, it's about how things are connected. So it's kind of like a society. It's kind of like, how can we all get along? Anyway, so like sort of that's what gets me
it's
to
like
a place.
We are the world. But
exactly. So then maybe it could be but it's a graph theory, but it's like we are the world. Exactly.
Now, obviously, you've got kind of a playful style. So how do you find that people respond to that when you're talking about AI and this?
The way that I grapple with new things is I try to play with them a little bit and I try to see the connections and see what's fun about it and how it could be useful in a creative setting. And I find that to be, at least from a problem solving point of view, really useful to be in that playful headspace and not the like, oh crap, I have to get this done, or wait, if I don't solve this problem, the world's going to end, right? I find that's not a great headspace to be in. It's more, even when it's a serious topic, to be a little playful about it helps make those connections to get to the answer. And so that's kind of how I convey things as well. It's like, don't be afraid of the content of this. First, let's work the content through in a playful way. Then you can take it seriously and figure out how to actually bring it to bear on the real world.
So how should we be taking that spirit and talking about AI going forward? Like, what are we missing in the conversation?
I do think that the conversations that start from a place of this is really weird and powerful and ununderstandable, like this is alien to us, that takes us to a really bad place where we're like, well, okay, then it's going to be used to overtake us and we should stamp it out, or like, there's no hope. There's not, like, it doesn't matter what I do. It's going to trample me. Like, I just don't think any of those things are particularly positive. And AI is just a thing. It's just a concept. It's just a set of ideas. And so, or maybe it's software, but it's not magic, right? And it's not an evil spirit. And so I think puncturing that and getting to okay, well, what is it really though? You know,
math.
Sometimes it feels, yes, it's kind of math. I think it's useful to think about a chatbot sometimes as an improv artist, which there's a lot of great improv here in Edmonton. So like that feels like a good connection to make. It's just riffing. It's it's just taking pieces and throwing them together in interesting ways. And that's a more useful way to think about it than it's got a soul and it's trying to like manipulate me in some way. We're the people in this equation. We're the people. We're in charge here. The programs are not in charge. They're programs. So you're not a PDoom person. Like you don't you're not worried about the coming apocalypse, AI apocalypse. I'm not. So it was maybe 2015, 2014. A person just contacted me out of the blue. This happens to me sometimes. I just got an email from a person saying, "Hey, you should look at this," and pointed me towards some of the discussions happening. And I'm like, what are you even talking about? And then, so I just wrote back saying, yeah, that's really interesting. Sounds like crazy talk. He's like, no, it's not crazy talk. Like these people really, really believe that that the AI is going to kill all people, and there's really nothing we can do to stop it. We need to like suddenly do a whole lot of research on AI safety. And so this stranger just started to talk me through the process of me learning about how the PDoom crowd thinks about things and how they talk about things. I would send like glib rebuttals and he would say, well, this is what that crowd would say in response to that. And so I kind of learned that whole argument space. And what he wanted, I later learned, he wanted to either know whether, once I was well informed, whether I would be scared and therefore he should be scared, or whether even once I knew all the arguments that I would still feel like, no. And he really wanted the counter arguments if I could generate them. I still don't have great counter arguments because it's such a weird space to argue in. It's so hypothetical. But no, I learned what I could. I think I get it. I think I understand the concerns. I think a lot of them are well formulated, but not properly attached to reality. Like I think if you look at the way that reality tends to work and how society tends to move, like that level of an idea taking over and that actually somehow subverting all of society, there's just like not great examples of that in the past. And I think there's a reason for that. I think there's a lot of momentum inertia in society that makes that really hard. So yeah, no, I end up not being super scared. It did though make me want to think about reinforcement learning differently, because a stranger said he was unsatisfied with my answers. He's like, you're not really engaging with the topic correctly. Because again, strangers say things like this to me. I don't know why. I just have that kind of face. And so he's like, you need to read this giant book. And I'm like, reading is a thing I'm really not good at. But I found an audio version of it, and I listened to the whole book. And it's called Superintelligence by Nick Bostrom, and it lays out the whole story. And I'm like, this is really interesting, because the book essentially has 3 parts to it. The first part is, where are we now? And it was meticulously researched, super interesting. Like stuff that I knew about, he wrote about really well. Stuff I didn't know about, I was fascinated to learn about. Then the last part of the book is, if we have superintelligence, if we have these kinds of machines out there, these are what some of the repercussions of that might be. And it's really scary for society. I was like, that's really well thought out. That makes a whole lot of sense. And then the middle section was like, ... and that's where we're going. And I'm like, no, you lost me there. Like, I don't see that story really cohering. I don't see us getting for the takeoff scenario where we go from, well, we have a good chatbot to we have superintelligence that we can't control anymore. And that's
like missing steps in between a little bit.
Yeah, I was not on board with all the steps that he went through there. It didn't seem certainly as coherent as the two sides, the before and the after, which I thought he did a really good job at. But I don't see the after following from the before. And so that's sort of partly what insulates me from the fear. It's like, I don't see us getting there. Like, but it could happen with really low probability. I'm like, okay, if it's all going to be about really bad outcomes multiplied by really small probabilities, then I will say to you, I do not know how to think about that. That is too hard for my brain. So if you boil it down, I think a lot of what they're talking about is, hey, we need really reliable ways of telling machines what to do. I'm like, oh my gosh, that's my research area. I love that. Yes, I'm 100% on board. But if it's like, we need to tell computers what to do, because if we don't, they're going to kill us all. They're like, okay, you lost me there at the end. I don't want to be on board with that.
I like that, sort of changing the problem statement slightly. And
and to the extent that they are working on that task, which they are working on that task, I support that. Okay. And I love that. I think that's what we want. That's why do we have computers if not to tell them what we want them to do?
That's why we made programming languages.
Exactly.
Well, that's a good place to move into the final question, which is, if you're thinking about how people should learn more about AI, are there things that you would recommend, resources? Your book?
Yeah, that's right. That's okay. All right. I'll take that bait. Well, I do have a book. I wouldn't necessarily have used that as the answer to your question, because the book is really about how we tell machines what to do. Mm-hmm. And I do think it gives this sort of nice perspective on the role that AI can play in that. But my sister is a TV producer, and she was looking for a project. I'm like, let's do a project together. It can be a documentary about AI, so that we can tell people the thing that they need to know about AI. And she's like, well, what do people need to know about AI? Well, the question that I get all the time is like, how scared should I be? And this how scared should I be comes out in lots of different ways. Mm-hmm. So there's like, scared should I be for my job? How scared should I be for like the future existence of humanity? How scared should I be about whether students are going to be able to continue to learn things? Mm-hmm. So there's so many questions that somehow this technology has raised in people's minds that it would be useful to kind of address them. And I haven't seen anything like that, but if I were to create such a show, I would call it something like, It's Not As Bad As You Think.
With Michael Littman.
I'd watch it. That title's got me.
Hey, well, thanks so much.
Thanks for joining us, Michael.
Yeah.
Oh, this is super fun. You guys are great.
Yeah, it's great talking to you.
What a great conversation with Michael.
Yeah, he's seen and done so much.
And with such a great spirit, too.
Yes.
And fun infused through it. And I mean, I hope that I also will get to the end of my career and still be smiling like that. Not that he's at the end of his career, but you know.
No, he's still got a lot to do with it.
Yeah, and a big role now with the AI Provost gig.
And a lot of great insight into what people should maybe be hearing and learning about when it comes to artificial intelligence. And, if you want a really good way of doing that, I've got a podcast I might recommend.
Which one?
It's called Approximately Correct.
You're listening to it right now.
Yes. All right. And the best way you can do that is by subscribing to us. You can get us on Apple Podcasts, you can get us on Spotify, and then we do also have a video version that's up on YouTube.
And if you're watching us on YouTube right now, you can jump down into the comments, leave us a comment, tell us what you would have asked Michael if you were here.
Yeah, and if you have any parody songs you've done about AI, we definitely want to hear about those too.
Or recommendations you think we should listen to. So with that, great episode. I'm Alana Fish.
I'm Scott Lilwell.
And this has been Approximately Correct.